5th, we learned how to find GCF, greatest common factor, and we started talking about LCM, which is the least common multiple. So this is a video that's going to just give you the nuts and bolts of what you might have missed if you had any technology issues or couldn't hear today's meet. And so I'm going to be summarizing and going through what we did in class for today. We talked about Alicia's problem with crackers and cheese. She's putting cheese cubes and crackers onto small plates. She has 24 cubes of cheese, 40 crackers, and she wants to put both the cheese and crackers on each plate, and each plate she wants to have the same number of cheese and the same number of crackers on each plate, similar to what we did yesterday. What's the greatest number of plates she can make using all the cheese and all the crackers? So it's the same topic of putting things into groups, and we want the same number in each, but it's not a box like yesterday, it's a plate. So we did some thinking on our own, and we practiced finding the GCF of 24 and 40. And there's a couple of different ways that you can actually go about finding the greatest common factor. We can make a table where we're putting the factors in columns. So you see 1 times 24 is 24, 2 times 12 is 24, and so on and so forth. So the top are the number of plates and the bottom is the number of cheese. We could do the same thing for the crackers and make a little table. We saw that in a practice and problem solving page, number 7 yesterday in your practice. You can also just make a list that's vertical. You have the factors here, 1 times 24, those are a factor pair, 2 times 12. And I know that many of us are used to the list, but you do it horizontally, which is what I've written out here. Same list exactly as these vertical ones in your book, but I've shown you the factor pairs by actually doing those arches, and those colors are the same. And then I've gone ahead and circled the common factors. And you see that 1, 2, 4, and 8 are a common factor. And so in this case, it would be that 8 is the greatest common factor. Therefore, she can use 8 plates and have the greatest number of plates to be distributed with equal number of cubes of cheese. There will be 3, and then crackers will be 4, if I'm remembering correctly. Yes, there's 40 crackers. So that is probably the way that you might have tried this. I'm going to show you a new way to do it to find the GCF using what's called prime factorization. So let me just get my marker and pen working here. So if you wanted to, with larger numbers, instead of finding all of the factors, you can find the prime factors that will be all of the prime numbers multiplied together to be 40. In order to find those, you can pick any factor of 40 at all. You can do 4 and 10. And notice I have written or drawn 2 what's called branches or lines down. So 4 times 10 is 40. And these numbers 4 and 10 are not prime. So I'm going to think of 2 other numbers that multiply together to get 4. So that's 2 times 2. And 10 is 2 times 5. So all of these numbers, 2 on this level, are prime. Remember, prime numbers are only factors are itself 2 and 1. And the only factors of 5 are 1 and 5. So this kind of third row right here of numbers, if you multiply them together, will give you 40. 2 times 2 times 2 times 5 is 40. So you have these numbers as your prime factorization of the number 40. So 2 times 2 times 2 times 5 is 40. I'm going to extend this up a little bit. What you can then do is the same idea with 24, your other number, any two factors at all. What's nice about this is that you don't have to try to think of all of the factors when the numbers get bigger. It gets a little trickier to remember all of them. So this is a trick to try out if you're struggling with remembering your factors. So I've picked any two factors of 24 and I've written them on the second kind of row, but 3 is a prime number. So I'm actually done with 3. I want to bring it down to the third level. And I do have 8 as a composite number, so it's not prime. So I have to keep going until I have all numbers that are prime. So notice this third level still has one number 4 that's not prime. So I kind of have to keep dragging my prime numbers down until I get all prime numbers. So I'm getting 3 2s and a 3. So right underneath, see how I've written 40 equals? I know it's a little messy. Let me rewrite this. So 40, my prime factorization for 40 is 2 times 2 times 2 times 5. And then for 24, I'm going to write it underneath. I'm just copying the numbers. And I'm actually going to put my 2's first and then 3. So I've just kind of copied this over. I've just switched it so my numbers are from least to greatest. And now, same as my list, I'm going to circle what's the same. And my GCF, whoops, sorry, my pen's getting a little funky again, is going to be, whoops. There we go. My GCF I'm going to take what is circled in red and I'm going to multiply. There's 1, 2, 3 circles. So I'm going to take that number and multiply it 2 times 2 times 2. So there's 2 2's in this circle, but I only need to represent it once over here. And so I'm going to have 2 times 2 times 2, which is 8. So it's a different way. There's a little bit of steps to it, but the main reason why you might use this prime factorization way is to avoid having to write and figure out all of the factors. Again, if you wanted to do a list, that is totally okay as well. Just wanted to give you that option. The other thing we did in class today was review the distributive property. We talked about that yesterday. And we're going to use the GCF and the distributive property to write 18 and 45 as a product. So we did 2 more examples just to try to get us more used to how this works because it does take a little bit of practice. So I'm just going to go through that with you briefly. So 18 and 45, we have to find the GCF of 18. So I'm going to model the prime factor way just to show you that again. And again, 2 is a prime number. So I have 3 times 3 is 9. So I'm getting prime numbers for 18 as 2 times 3 times 3. Now I'm going to do the same prime factor for 45. I'm going to do 4 times, whoops. There we go. 5 times 9 is 45, and 5 is prime, so I'm going to drag that down, but 9 is not. That's 3 times 3. So I'm getting all my prime factors I'm actually circling, so I know that they're prime. So 45, the prime factorization is 3 times 3 times 5. Now the fun part happens. We get to circle what's the same. There's 2 numbers that are the same. So to find the GCF, we take one number from the first circle, one number from the second circle, multiply them together, and we get a GCF of 9. Yay! Now, once we find that, that goes on the outside of our parenthesis, and the factor pair goes on the inside. So what I was saying yesterday with the numbers inside, you can use arrows to help you think about it. So 9 times something gives you our first number, 18. So what's the factor pair that goes with 9 that gets you to 18? That's the 2. And then do the same thing for the second number, 45. What times 9 gets you to 45? We actually did that right over here. This is the factor pair, and so the 5 goes on the inside. And we can always double check it by doing the math. 7 is 2 plus 5 times 9 is the same as the total of 18 plus 45. So that was prime factorization, and as a way to get to the GCF. We did another example as well, and I'll just show you that 30 and 24, you can find the factor pairs with that factor rainbow as well. So you are thinking, I'm going in order, 1 times 30, and I'm giving a lot of space because it's the bigger number. So 1 times 30 is 30, and then I'm going 2 times what is 30, and that's 15. Then I'm going to the next number, 3. 3 times what is 30? I have 10. Then I'm thinking, does 4 work? 4 does not work. It's not divisible or not a factor of 30, but 5 times 6 is. And now I have all of my whole numbers for the factors of 30. Then I'm going to do the same thing with 1 and 24. Factor pairs. Go hand in hand. I actually forgot to do the actual pairing of the arches, but we can do that as well. The 3 goes with the 10 and the 5 goes with the 6. There we go. Back to 24. 2 is a factor, 2 times 12. 3 is a factor, 3 times 8. And 4 times 6 is 24. So we have our factor pairs here. And those arches, pair those up. Now I'm going to switch to yellow so that I can circle everything that's the same. Our 1s, our 2s, our 3s, and our 6s are the same. So the greatest common factor is 6. That's the first thing you have to find before you can finish using the distributive property. Just going to put my marker in here and extend this a little bit. So now we have 18. I'm just going to write that. Not 18, sorry. We have 30 plus 24. I'm just going to write that here. We're writing this as a product using the 6 as the greatest common factor. And then the factor pair of 6 goes inside. So if you are doing this, the factor pair of 30 is 5. 5 goes on the inside. And the factor pair of 6 for 24 is 4, so the 4 goes on the inside. And again, you can add it up and then do the multiplication. 6 times 9 is the same as 30 plus 24. So we practiced that as well. The final thing that we talked about in class is least common multiple. So this lesson 11, deals with both topics, GCF and least common multiple, which we call LCM for short. So we talked about Jackson, and he wanted to buy the same number of stamps and envelopes. Stamps are sold in packs of 6. Envelopes are sold in packs of 4. And we want to know the least number of stamps and envelopes he has to buy. Because we see the least number here, we're not dealing with GCF. We have to find multiples of 6 and 4. So one way you could think about this is with number lines. You can see 2 number lines here, and you see counts of 4 circled in red, and then counts of 6 circled in blue. And you can stop as soon as you get a number that is the same in both of your lists. So if you notice, the second multiple example is going above and beyond where you really need. When I'm doing my lists of multiples, I use this method more than my number line method. I'm starting with the number in the problem 4, and I'm thinking 4 times 1, and I'm writing down the product. So these numbers will be bigger than the numbers in the problem. Multiples are bigger than the number you start with. So 4 times 1, I'm writing down the product 4. 4 times 2, I'm thinking in my head, and then I'm writing down the answer. 4 times 3, and then I'm writing down the answer. And then I'm doing the same thing for 6. 6 times 1, writing down the answer. 6 times 2, writing down the answer. And then I would stop. As soon as I get a match, I have found the smallest number that appears in both lists. They continue. Yay, hooray for them. You don't need to. Okay. So that's the new part. The least common multiple is something that we practiced today in class, if you missed it, or if you needed an extra review on what we did, if you wanted to hear it again. The other thing that I did mention is that you can use prime factorization to find LCM as well. It's very similar to GCF. You start out with your two numbers that you need to find an LCM of, and you find their prime factors. In this case, we only need to do one level. Whoops, I was thinking ahead here. And 2 times 2 is 4, and 2 times 3 is 6. And all of these are prime numbers. So when you're writing the prime factors horizontally to just organize yourself, you only want to circle what's the same. And so there's one number that's the same. And to find the GCF, it would just be 2, because there's no other number to multiply it by. So it's just what's in the circle. It's a 2. So that's the GCF in this case. We didn't need to find that. We needed to find the LCM. But at this point, you can use these numbers to help you find the LCM. So just like we have one circle, we only represent that number once because it's an overlap. So we don't need to double it because it's in both lists. But then we actually have to multiply it by all the numbers that are not the same as well. And when we do that, we have our least common multiple. 2 times 2 is 4. 4 times 3 is 12, like we saw in our other list. So that's an option. You don't have to use prime factorization. You can just list your multiples like this until you get one that is the same. The final thing that we did discuss was, how do you figure out what to do? If they don't come out and tell you the least, find the least common multiple or find the greatest common factor, because sometimes they will ask you directly, hey, what is the greatest common factor of 4 and 6? Other times, though, it's kind of hidden. And you might see words like greatest number of or least number of. And when you do, that's the clue that, hey, greatest common factor, least common multiple. So those keywords do apply. If you see that, then that'll direct you to which one to find. The other times, they don't have those words, greatest or least, but they're dealing with two different ideas. Both our boxes and our plates were grouping different things into equal groups. We were grouping our cheese and crackers onto plates. We were grouping banners and posters into boxes. That's a greatest common factor type of question. Anytime you see that happening and they don't ask you directly, that is a greatest common factor question. The other thing you'll see is when will an event happen again? It'll be this nice little story about one train leaving at 5 p.m. and another train leaving at 6 p.m. And when will the trains cross each other's path again, or something like that. I was kind of making something up. But when an event will happen again, that's a clue that it will be an LCM, least common multiple kind of question. So LCM, will an LCM ever be less than the numbers in the problem? No, multiples are bigger and they start off with the number and then grow bigger. And then we tried this together to finish off before we did our pair deck. So this is an example of when will something happen again. So Danny wants to promote his new business. He's going to get a free pen for every 4th customer and a free pad to every 7th. So this is a situation where we found the LCM. So that's basically the instruction. Now you're just practicing with LCM with this, and then you are practicing in Pear Deck and practicing in your practice and problem solving. So hopefully this was a shorter way to get the instruction. And if you have any questions on your practice, come see me during academic support. Thank you so much. And hopefully give me some feedback on whether this was more useful than my recorded meets that I've been doing so far. Thank you very much. I'll see you later.